I'm going to start now part 2 of my document number 5, Introduction to Math Operations. In document number 5, we are analyzing numeric and expression functions. In part 2, specifically, we're going to talk about functions that apply to expressions. So we're going to continue with the document that I have prepared over here. We talked about these purely numeric functions in the last video. And right now, we're going to talk about functions applicable to expressions. And so I'm going to repeat these ideas using the example that I presented in here. I created an expression, I call it expr colon, and that is equal to alpha, A, control G, times cosine, parenthesis B, control G, spacebar, raised to the square. And spacebar divided by sqrt, square root of 1 plus parenthesis D, control G divided by 2, spacebar, raised to the 2/3. That's the expression I define right above and show you how to do it step by step. I'm going to delete it since I already have it right here. So this expression has a number of variables that need to be defined before you can evaluate it. The function eval can be used to evaluate an expression that you defined before. In this case, it's going to tell me, well, alpha is not defined, of course. And so one way to check if all the variables in an expression have been defined is to use this function called isDefined. And if you get a 0, that means not all the expressions or all the variables in the expression have been defined, and you need to define them. So I define them by assigning values to alpha, beta, and delta. And if I now, after you define those values, alpha, beta, and delta, if you apply the function isDefined to that expression, you get a 1 indicating that indeed the function has been defined. Now that I have values for alpha, beta, and delta, I can use eval expression to give me the result of that expression. This is equivalent to simply saying XPR equal. So eval is an alternative way to say simply calculate the right-hand side of this result. The function num then separates the numerator and denominator of these expressions. Because I have evaluated those values, let me copy, select here, do Control C. I'm going to do Control V here, equal. Okay, I have to lift it a little bit here. And so it gives me a result there. And the denominator, I'm going to put it over here. And I'm not getting the results presented in here. So you want to use this numerical numerator-denominator expression with a purely unevaluated expression like this one. Otherwise, you get something strange here. I'm going to check something. If I take this numerator, put it over here, and then divide by this denominator, I do indeed get the result that I expect, but I don't know where those values come from. So don't trust that numDem function after you have evaluated. Trust it before evaluation. How can I do that if I have already evaluated? Well, you could use numDem over here, or you can do the clear function. The clear function with uppercase C simply takes all variables you list in there and clear them up, eliminating the values. So you don't have values of alpha, beta, and delta past that point. And if you get an equal value of 1, it means true. It means that alpha, beta, and delta have been clear. And so if you use the numDem numerator-denominator expression on the expression XPR, it will separate the numerator, as you see right there. Although it did some manipulation of the denominator to eliminate that 2 from there, and so it's not quite what you expect, but it will be the numerator and denominator after the equation has been simplified, or the expression has been simplified from the from the original version. So if I copy these over here after I have defined the values, I'm still not getting the values that are supposed to be here. So the idea then to use numdem is to separate the expressions of numerator and denominator, but you got to be aware that SMath Studio is going to do some type of simplification, and so you're not going to get exactly this numerator and this denominator. This could be useful for programming more than anything, so don't worry much about interactive calculations. Then we have the function sys. The function sys produces this brace with two placeholders, and it's equivalent to this icon. And so it is useful for defining several values of a quantity. And I want to demonstrate in a different page how you can add placeholders. If you use the function sys, you start typing SIS parentheses, and automatically it will give you that. If you select a point in here and click this button, you get the same result. Now suppose that you want 3 or 4 placeholders. What you have to do is click to the left so that you produce this little black block in the lower right corner. And what you have to do is hover the cursor over it until you get that type of a double arrow. Hold your mouse button. Let me try that again. And lower it again. Let me try that again. Oh, I have some difficulty with my mouse here. Let me try it over here. Okay. Once you hold it, you can make it as long or as short as you want. And so in the other document, I have examples where I drag that to be 3, 4, 5, up to 6. One way to use this is to, let me go to the other page, to create several functions to plot. So suppose that you define these 3 functions and you want to plot them in the same graph. What you want to do is go to Insert, Plot 2D. I should have went down here. I'm going to make a couple of deletes there. And then, actually I'm going to put this over here a little bit higher. Click in here. Click on the sys function or type. Right here you can type sys parenthesis. And then click on the left side of the brace. Drag it down for 1. And here you can type your functions f of x, p of x, h of x. And then it will show the plots of the 3 functions. If you want to see it in more detail, you can drag it down. Click on here, hold down the shift key, move your mouse wheel forward to produce more detail.